All right. Well, cool. Well, welcome to Design Analysis Foundations. I know most of you guys from senior design, which is really convenient for me. And congratulations, all of you guys in senior design have just been upgraded to my new favorite compared to everybody else in the class. And you can tell everybody else that who did not take this class. The best way I can describe this class is like a geotech part two. We're going to go over some of the specific like goals and learning objectives here in a little bit. But what you'll see is like geotech is just such a big, like diverse topic that we can't just cover it all in like CEG 3011, whatever the first class, So especially on the FE and the PE, like the stuff that you'll see under NCES, the things that are covered in geotech, like we're going to be able to cross a lot of that off of the list of like understanding through this class, where with the first class we just simply don't have enough time. Let me just, is there full screen or something? But yeah, so if you've taken other classes with me, everything is going to be very similar. Canvas is going to be kind of the home page. Everything's on that. Our lecture notes, I will be posting shells of lecture notes. Since I've taught this class a few times now, I will make sure that they are posted like the weekend before, the Friday before. So you can either print them out, bring them here, or if you have a device, download them as a PDF and take your notes on that. I will say like this class is a little bit more heavy on the analysis portion. So like if you're writing with like if you don't have something to write with, then I would definitely bring a notepad or something. There's going to be more calculations. There's going to be more like actual equations that we're writing out rather than just fill in the blank style concepts like we may have seen in some of the other classes. So lecture obviously is here. It's going to be Monday, Wednesday. This is an interesting time, but at least it's not right after lunch, so we're not super tired. Attendance, this is a senior level class. I'm going to say attendance is expected, but I'm not taking attendance. You will definitely, this class will be the easiest for you to pass and succeed in if you attend class here and can ask questions. But that being said too, everybody has different work schedules. I am recording all of the lectures and I will post the lecture recordings on Friday morning, just like all my other classes. Again, but so if you'd rather do that thing and you have stuff pop up, that's fine. But you will definitely get the most out of it because this class is not like for geotech and just foundation design in general. It's almost like an art in a sense where like there's a lot of interpretation that needs to be taking place before we add a calculation or an analysis to it. So like the more you can bounce ideas off of me, bounce ideas off of your classmates and kind of understand the intricacies and the different ways of viewing failure of soil, then that's just going to be easier done here than just reading a textbook over at home or something. So all the PowerPoints, it's fill in the blank, whatever, you guys know all this stuff. So if you have a stylus or if you have a way of writing, or you can print out the lecture notes ahead of time and bring them here. I try to leave enough room for all of the writing of the equations and stuff. And you'll see when we do go over the homework solutions and when we do go over exam solutions on your exam, I'll leave enough room where we can kind of do it and do the calculations in person. So like everybody's different, obviously. Like if you're really into just like learning by like listening and then going back and reviewing the lectures, like feel free to do that too. I'm not, if I see you not writing, I'm not going to call you out in class or anything. Canvas is our home here. Quizzes, homeworks, lecture notes, everything will be on Canvas. Your exams will be take-home exams over a weekend and a couple weekdays. And I do that again just because of everybody's work schedule. We have 2 exams, and these exams are analysis based where there is no like exact answer. I'm grading based off of the methodology. I'm grading based off of the background information, the due diligence ahead of time, and then your like understanding of it. So with that being said too, we don't have enough time in class to solve a foundation problem, like especially one on an exam. So just giving you a heads up ahead of time, like you'll see on the syllabus, I do have those exam dates scheduled, but there's going to be buffer days ahead of that as well. But everything is going to be submitted through Canvas on there. For communication, please do not use Canvas messaging on Canvas for communication. You guys, again, classes with me before, Outlook and Teams is going to be the best bet. So please, I'll create an Outlook, or sorry, a Teams group, whatever, team for this class. If there's not one already, then you can send me a message on Teams. I have it on my phone, or Outlook email as well is going to be the best thing. As far as office hours, or so, yeah. The classes are recorded, so keep that in mind. I'll start the recording, I'll stop it like after everything. We'll have some time after. I will pause it, like, so, you know, if you come up and ask me questions right after class, I'll make sure to pause it so your questions aren't on the internet forever. But the lectures they're going to be posted each Friday, and again, I'll try to do morning, but at least what I will do is by noon, they will be posted on Canvas. It'll be the same thing. It'll be a YouTube channel. You can speed it up, whatever. You can see it through there. And again, just similar to the other classes, I'm going to have weekly quizzes that are going to be due at midnight each Friday. So those weekly quizzes are based strictly on the lecture on Monday and Wednesday. And they're not super exhaustive. They're not super intricate. They're mainly going to be, hey, did you understand, and like, are you like keeping up with the class for those learning objectives for that week? You know, just so it's for your benefit. It can be annoying just to do these quizzes, but they should not take more than 30 minutes. At the beginning of each quiz, I'll give you a heads up. You know, this is a time limit of 30 minutes, time limit of 15 minutes, whatever. If you have your lecture notes handy, if you were sitting and listening and doing the example problems that we did in class, then these quizzes should be no sweat at all. So, but it will help us just keep pace with it, especially with everybody suffering from senioritis in this class, which I know everybody has already been prescribed stuff for that. So, so the exams will be held at home or at office, whatever you want to say. Like, so like they are take-home exams, and I will share more details before each exam as well, with the time limit that we have allotted for that. I am giving you more than enough time for these. Like, you know, at the end of each exam, or at the top of each exam, I ask you to actually like kind of write an invoice of how much time it actually took you, you know, so just keep that in mind too. Like just because I'm giving you 4 days to complete this exam, like use your time wisely. Like don't use all 4 days up and just stress about it the whole time. Like be confident in your answers. And as I said before, there's no like true answer. There's going to be answer ranges. Obviously that makes sense, but I'm looking more so for the whole story in your understanding of the problem, understanding of the background information, and how you did the steps to solve for whatever issue we're solving. The whole moral of this whole class is you'll see like concrete design's pretty straightforward. Steel design's pretty straightforward when it comes to physics and everything. Like we know those materials. With geotech, as you guys know, I've said before, like we're dealing with unknown materials, we're dealing with unknown site conditions, and we're dealing with like unknown failure types. So there's so many things we have to cover and ensure that we are checklisting and making sure before we can design a type of foundation, or what type of foundation we are designing. So for resources, everything you have for the class, I will give you. So you do not need to purchase these, but if you are interested in any type of geotechnical career or grad school or anything, I would definitely recommend these are the two like best textbooks, in my opinion. There's a lot out there. The ones from Geotech 1 are more so based off of like the preliminary, like soil classification, like site characterization, that kind of like preliminary stuff. These are more so based on foundation design and analysis. So you'll see there's a lot of the books are kind of categorized into geotech and then foundation. So if you have a random textbook floating around and it's just a geotech textbook, just look through and make sure we cover shallow foundations, settlement, bearing capacity, and deep foundations. Those are the kind of the main topics that we're going to be covering. And you'll see that in the syllabus too. I think some of these are around for a virtual copy if you log in through your UNF, whatever library stuff, but they change that every year. So don't quote me on that. But the one on the left is the one I use personally. It's really small and just very straight to the point. Like they have like 2 example problems per topic, very precise, and like kind of give you the worst case problem. So it's kind of helpful in that case. And then the one on the right, the DOS textbook, he's the dude who actually recently passed away, but he's been doing a bunch of geotech and foundation textbooks. And that's a little bit more exhaustive, like just has more words in it and all that stuff. So I would recommend choosing between one of these two. If you work at a place, ask your boss, see if you can borrow it, not spend the money. Or you can find these or pick these up cheap somewhere. Grading wise is pretty straightforward. Those quizzes are going to be 15%. We will expect to have about 8 to 10 quizzes. As I said, most likely going to be weekly, but in some cases where we have exams, we're not going to have quizzes, that kind of stuff. The homeworks are going to be 20%. This is a big thing where homework is going to make a difference compared to CE materials and geotech. Like this is a senior class now. My level of like acceptance for homework is going to be a lot higher like a bar for that. So there are 4 total homeworks, potentially 5. And out of that is 20%. And homeworks are going to be they're going to take a little bit more time than some of the other homeworks, just again, because of the nature of what we're learning here. So really don't slack out on those. I am keeping that late assignments are very important for this class. So like if it's late, I am going to decrease credit every 24 hours by 50% or whatever it says in the syllabus. I need to see what I said. So just, usually in the other classes, the homeworks are meant to just kind of prepare you for it, but these are going to be a little bit more preparing you for the exams and a good chunk of the grading here. Your exam 1 is midterm, and then our exam 2 is a final and weighted separately there. And then you'll see a design report. This one is going to be a little different for our grad students versus our undergrad students. This is more so going to be a research topic that we'll talk about after exam 1. What you'll see, again, moral of the story too with geotech is even 2 classes can't cover all of this stuff. There's different foundation designs out there that are still preliminary and still being designed. There's different case histories that we can learn from. So part of this design report is going to be you guys in groups or grad students individually, you guys will be doing additional research into one of these topics that we're not covering. And then you're going to be presenting to the class on that. And I'll share more details. I have some kind of interesting topics that you can cover. But if there's anything that you come across in your own careers or just driving down the road that you're like, hey, we didn't learn this and I want to learn more about it, this is going to be the opportunity for that. All right, you guys know where my office is. These are the office hours that we have to set, but you guys also know that I'm available anytime, most of the time. So just send me an email or send me a Teams message. Please, if you are doing either one of those, this semester, I'm actually teaching 3 classes randomly. It just kind of happened. So and a lot of you guys are in the other class too. So just keep it consistent so I don't get confused. Oh, is this a senior design question? Is this foundation question? So even in the Teams chat, if you could, if you're starting a separate one, put CEG4111 or 4101 or whatever the grad one is, just so I can keep it consistent too. But the best thing, I do have these set office hours, but for email, we can meet over Zooms or in person or Teams or whatever is easiest. So just set that up, and that'll be the best way of communicating. All right. So for some of the goals here, I've shared this before, and hopefully some of you guys have already been preparing yourselves for the FE. Has anyone taken the FE? Who's taken it yet? Okay. Has anyone signed up for it? Yeah, sweet. Okay, so we got a few signs up now. If you've already started looking at the whatever 400-page PDF that they give you, you'll see that there's a lot of topics in there that might be foreign to you, even if you took geotech. This is the list given to us for geotechnical engineering. You can expect 10 to 15 questions for this, and hopefully some of these are familiar to you, right? Like index properties. Who can name an index property that we've talked about in Geotech 1? Just say it. Moisture content, void ratio, densities, plasticity, Atterbergs, all the stuff that we did our labs for, way back when. It was only a year ago, but it probably feels like forever ago, right? So the index properties, soil classifications, what are the 2 soil classifications that we care about? Yeah. USCS, Unified Soil Classification System, and then AASHTO, so one for structures, one for roadways. Yeah, phase relations, so that's that crazy three-part thing where you take the mass and the density and using specific gravity, all those fun things from Geotech 1. Hopefully either the PTSD is triggering or you're like, oh yeah, I remember this, and it's kind of easy to remember. But if you remember, we talked about effective stress and we talked a little bit about stability of retaining structures. A lot of this here is most likely going to be new material, right? Like, and that's the goal of this class. We are going to start off on Wednesday, relearning effective stress, relearning density, and kind of talking about like how that now shapes the design of foundations. And so we're going to be covering the two main things we're going to be covering are spread footing, so shallow foundations, and then deep foundations. And if you look at your syllabus, the little calendar that I have at the front, you'll see that it's kind of separated into those two topics. We first talk about shear strength, and then we talk about the design of analysis. So a lot of these things here we've kind of talked on, hopefully a little bit in our Geotech 1, like, you know, saw the light at the end of the tunnel. Like, this is why we do this, because eventually you're going to need to do this. This is the class where we actually learn how to do that. And what you'll see too is there are so many different methods and theories out there to actually calculate shear strength. There's so many different theories out there to actually calculate bearing capacity. So what we're doing in this class is just covering the ones that are in the PE or the FE. So I'm good, but what you'll see is, and again, this is where it can get kind of tricky. Like, if you go outside of this class and let's say like you're like, oh, whatever, I'll just Google it or something and then find a video from like somebody in, you know, like Bangladesh or something, like they could be doing a completely separate like analysis problem. So just be careful with that. It's not like your statics where like, oh, you use method of cuts or this, and these are the two worldwide methods where you can find this information. Like here in the US, we're going to use Terzaghi, and Ashto has a certain way of doing bearing capacity. And so that's the one I'm going to teach. There's lots of different theories out there. There's lots of different ideas out there, but the ones in this class are going to be very specific for that. So just keep that in mind when it comes to exam and the content too here. So the biggest thing that I want, if you take anything out of this class, is understanding how geotechnical engineering, especially the analysis side of it, is different than some of the other classes and some of the other disciplines of it, you know, structures versus concrete. Really, the hardest part is first understanding how soil fails, right? So like in concrete, how does concrete fail most of the time? If you were to think like, oh, we have to design against what? Yeah, tension, right? I mean, that's like concrete is really good in compression. So like if we have concrete, we know it most likely it can fail in tension for bending or compression. Or what are some of the other things that we have to worry about for concrete, like failure types? Shear. Yeah, shear. And even with the shear, if you remember, like how you design against shear is what you just use the stirrups on the end a little bit better, right? And like shearing in concrete, that like is a 45-degree angle, and it's a straight line most of the time in our cylinders, and it's a little bit easier to classify, right? You see this like this failure right here. So for steel or just structural like metals or in general too, like what are some of the failure like values that we care about? Tension, yielding, right? This is stress strain curves, all those little things. So like we're looking for, again, tension failure. We have block shear. Block shear. We can have column buckling. And it gets a little intense, but really, if we look at it, a lot of this is just going to be a function of our yielding or like the moment of inertia, you know, like even in concrete, you know, the bending, the max bending moment, you can kind of boil it down to this material property here. Of course, with soil though, like you can kind of imagine, how does soil fail? Or like how could a structure fail like from a soil standpoint. Yeah, settlement. And that's kind of tricky because like settlement is what? Like settlement is just the decrease in volume. So like your building could be completely fine, but if your building settles 3 feet, what happens to everything connecting that building? And what happens to the runoff and drainage and everything? So like that can be considered a localized failure or even a global failure because like, yeah, your whole building could settle and that'd be fine. One of the weirdest, when I was working in, it's super ironic, when I was working at the Terracon office in Winter Park, the back of the building like settled like 3 feet or not 3 feet, 3 inches. And they had to like redo the whole thing and all the doors like closed bad. And it was just like awkward because it's a geotech company. And we're like, hey, we should have caught this, but they built it on like the back of this like big muck area. And it's a super old building. And like the building was fine. You'd never notice it going like walking in, but there was this one door that like you had to do an ADA step down. And then since you had to build that up, like the door was just low. You had to, like kind of step in a little bit. It used to be a normal sized door, but the whole thing settled about 3 inches and you had to like just kind of be careful walking into it. So like accessibility is fine, but like, is that deeming a failure or is that like in that case, no, but we could have a case where settlement is an issue. The other thing with settlement is what that we'll see is settlement is also time dependent. And this is going to be something where we talk about like clays and this fun word called consolidation that you'll see we're going to be touching next week. It could all settle before people get in the building, before you connect all the utilities or before, you do all of the things and people that inhabit it. Or it might settle 30 years from now or 20 years from now and then really screw up everything with a slow process. So like settlement is a function of time, which is another headache for that. What about other types of failure? Sinkhole? Yeah. So what do you think? Yeah, sinkhole is yeah, definitely. Yeah, erosion is one. So this is a big function of water, groundwater. Yes, steel can corrode and concrete can corrode as well, or like if water keeps like can erode or what weather. But soil erosion failure is pretty common, especially in Florida. Like just making sure your downspout is in the right spot and you're not undercutting your foundation is a huge thing, and a very thing that's often overlooked. That's a function of water. Other types of things like, sinkhole kind of along the same line, that would be like a collapse. So this is a function of the subsurface, whether it's a natural like void in the limestone like you see in Florida, or like old sewer pipe that was abandoned 50 years ago and the city forgot about, or an old like subway line in New York City that has been abandoned forever, and you forget that it's there, you don't do the correct subsurface analysis, and then boom, you just did all this work on top, and then the strength or the soil underneath it gives out and your structure gives out and you're screwed. The other type too that we'll see is the biggest can of worms is the shear failure. So soil is a individual particles, right, that are all interlocking with each other. And we kind of talked about this in Geotech 1, but the way soil fails typically, like how you would say like concrete shears, soil also, that's the main mechanism of failing as well. Like, so there is enough pressure that the particles decide to roll over on top of each other. And that particle rolling then pushes the other particles, which pushes the other particles, which then cause like a failure plane to develop and then causing the whole thing to move. Now, the issue with this, though, is this happens on what scale? So if you guys have ever gone to the beach or something, right? We live in Jax. Like whenever the nor'easters come through or like a big swell, you have this big scarp coming in from where the waves come, right? You guys know what I'm talking about? Like it's like just the water, whatever the beachfront. I'm sure Dr. Daly knows the official word of it, and then you have the nice fluffy sand on it. Especially if you grew up in Florida, what was the fun thing to do? You walk up to the edge of it, you jump, and then the whole thing collapses down, and then you like go falling 3 feet into the water, you know? Like, so that is a little localized failure caused by you jumping on that specific point, you know? Similarly, like if you've ever walked, again, a Florida reference, if you ever like walked in a swamp or something, like you could be walking on the sand and be perfectly fine, but as soon as you step in the mud, what's going to happen? Your foot is going to sink into it. Like, so what's different between the sand where your foot didn't sink and in the mud where your foot did sink? So that's a localized failure again. So what we have is there's different scales here where we have localized failure. And then we also have what's called global failure. Has anybody heard of these terms before? Not like financial crisis or anything, but I guess it could be used interchangeably. The global failure is a little exaggerated, in my opinion, I think. Like, it doesn't mean like, oh, global. It just means like the soil outside of the direct footprint of our structure or loading, whatever's happening, this also fails, which can be pretty catastrophic because, like, yes, you build this brand new building right in the middle of downtown, and like you're hoping that it doesn't affect the other structures nearby, right? You know, or the roadway nearby or something. So not only like for concrete and for steel, whatever, we have like the material actual failing, and that's usually what we have to check with. But for soil and for foundations, we have to check settlement, whether that might fail, erosion, whether that might fail, collapse, like subsurface, as well as shear on the localized and the global side of things. And the other thing that is going to be that I didn't mention, along with collapse, we also have something called heave, which we don't really worry about here in Florida, but as you know, like soil changes throughout the whole United States. The whole rest of the United States right now has snow on it and it's super cold, and we lucked out here in Florida. Like, so soil has different issues and different problems depending on the climate, depending on the soil conditions. So we might have heave due to frost, freeze thaw conditions, you know, like you've all driven in Georgia where it says ice may free or road may freeze on whatever. Up in Vermont and like some of the areas up here, you may have seen some of the signs saying in the wintertime saying like roadway frost heave advisory or something, where it's almost like a reverse pothole. It pops up out of the ground and you have these speed bumps then you have to worry about. So again, the issue is like we're going to be focusing a lot on Florida things, but some of these are a little bit different depending on where you are, especially out on the West Coast where you have severe drought conditions, earthquakes, and all that seismic stuff too.
Is this it's heave related to when we have to look out for frost depths when like for buildings?
Mm-hmm. Yep. Yeah. Heave. That's why a lot of times, like, well, it could be either way. Frost steps are meant like to protect the building. Like, so like up north, a lot of buildings will just be on piles anyways, so you don't warm up the ground and cause differential settlement, or also so the building doesn't like pop up in a certain area. And that's a good point too, because like with the settlement example too, again, I'm just trying to convince you guys that this is a hard class. But there's just a lot of things in it. But for the settlement, like if the whole building settles 2 inches, that might not be a big deal. If the whole building heaves 2 inches, that might not be a big deal. What becomes an issue too is when you have the differential settlement. So one half of the building rises and the other half sinks. And then that throws off all of our structural analysis because now our beam is not perfectly fat. It's sideways and now the loading's all over the place. So like that's the biggest issue most of the time, is that differential settlement. We will cover that too. So yeah, all this to say, a lot of things in this class, and we do try to cover it here. That's why we have like different foundation types to solve some of these different issues. So like if you were just to Google, and I didn't do this, but I usually will show it at least, like just Google like steel design in Google Images, and you'll see a lot of pictures that look like kind of similar things. You know, you'll see like pictures of steel, concrete design, a bunch of things like parking garages, everything. If you just Google foundation design, like you'll see deep foundations, like drilled shafts, like shallow foundations. There's just so much out there. And also, since we're only covering the mechanisms of shallow and deep foundations, just know still, like you might work in a field and be like, oh, we do a lot of augered foundations. Like we just don't have time to cover that in this class. Again, if you're interested in geotech, a master's would help a lot because, and that's why like they're starting to lean towards wanting to require that. Like some firms only like require foundation or masters of it because there's just so much to learn in this topic. But the thing is, like, not only like do we have, usually what we see are like these types of foundations, right? Like, but what we're going to get into is how to choose which is best. At the end of the day, geotechnical engineers are consultants, meaning the owner comes to them and they say, all right, I have this much X budget to spend on the entire project. I need to figure out what the subsurface conditions are. And then I also need, or I need a foundation. The geotechnical engineer will consult and provide the best type of foundation and recommend a certain amount, but they usually don't do the construction itself. They'll bring a specialty contractor into it. So as being a consultant, you need to have the mind of an owner and be like, all right, there's a lot of financial liability involved. Like, how do we choose which one is best? Could we do a deep foundation pile like this? Usually this is going to be the most expensive one, but the least amount of footprint. And we'll talk about the different soil conditions that might warrant this, the type of loading conditions that might warrant this. In this case, like these large raft foundations, what do you see? What is it made out of there? Yeah, a lot of rebar, a lot of concrete. So like you have to get the concrete out to the site. You have to think about like transportation. You have to think about like if there were to be a redesign of it, you know, like piles are underground, you can sometimes abandon piles or remove piles. Doesn't seem like you would want to remove this at all in case you needed to change something. And then our spread footings too. And don't feel like you need to write on here. We'll recover all this stuff, but the size available for it. So do we have enough square footage to actually make a spread footing large enough to distribute the load across the soil, given the dead weight of our structure, the loading of our structure, and you know what else we have. So once we even choose what type of pile to use, like the failure aspect is one of the most difficult parts. As we said, like for shallow foundations, I'm just going to draw it like this. Shallow foundations are usually at the surface or like directly below the surface. When we load a foundation like this, we might expect some potential settlement. And we are going to talk about ways of calculating that. And that might be a concern if one spread footing settles and the other one doesn't, like if you're not on like monolithic, if you have like multiple spread footings. But when we go back to talk about the shear aspect of it down here, we'll see like what type of shear should we expect? I should have just shown pictures of it. But what we'll see is this is where the shear path, the best way I can describe it is an art that we then add math to it. So this is where you have the different opinions on it and everything. Like for concrete, when we concrete shears, we see it's a 45-degree angle, right? We talked about that. When soil shears, does it look like that? Does it look like that? Is it more global in a larger area like that? once we have that path and we can define that line and we know the resistance versus the stress, like we can calculate and do all the fun math equations on that. But the first part is that art of understanding how exactly shear failure occurs first. So preface that again, like, and we'll come back to this whenever we actually start talking about the different ideas and methodologies to design this stuff. Like a lot of it is up to the interpretation, knowing the local geologic conditions, knowing how stuff actually fails here, looking at case histories and the designing it based off of that. So for deep foundations, one of the things we'll actually get a chance to do this class too, hopefully, is anyone familiar with First Coast Expressway? Like the big construction site out there and stuff. That's a really unique thing where they are driving like 60-inch piles, which are huge. And I've been in discussion with 60-inch diameter, which normally you would, I mean, I've never seen that before. So we're hopefully going to set up a field trip where we can go out and see that. The soil conditions for the embankment, especially on the north side, like the Green Cove side, is really, really poor. It's just that St. Johns River is super old. It's just been dumping organics for a really long time. And it's such a large, like, loading on the embankment load that they're doing these huge piles. So the WSP is the geotech, and we've been talking about hopefully like setting up something where we can actually go and see the pile driving of that. So pile design, and we'll talk about this too. There's similar to shallow foundation design. There's a lot of considerations. The resistance from piles is all going to be along the shaft mostly, because most of the time piles are going to be thinner, 12 to 24-inch piles, right? But when we are talking about 60-inch piles, we can actually get capacity at the bottom as well. Now, when they're driven, you also have to consider the force it takes to drive them into the pile, into the ground, before we actually load it. And so we actually have to consider the material too. Like, is the force required to drive this? Is it actually going to be too much that we break the pile and then it's useless, you know? So there's a lot of things behind the scenes too that you have to consider when it comes to pile design that we are going to talk about. So long story short, like, that's why in the class, like, you'll see we kind of divided it this way, and there's a lot of weeks just covering one thing because there's so much stuff that we can talk about when it comes to shallow foundations. And there's so much stuff that we can talk about when it comes to deep foundations. And really all we're going to be covering is pile design from a roadway perspective. And that's part of that project where you're going to be looking at other types of designs or other types of construction or design techniques for the different types of piles or different types of whatever foundation that you can actually then try to solve. So the week is set up this way. We'll talk first about on Wednesday reviewing geotechnical basics. So if you still have your geotech notes handy, like, I would look back at the last few weeks, you know, right before finals, when we started talking about effective stress, we started talking about total stress and pore water pressure. That's going to be like one of the most key things that then set the stage for the analysis side that we're going to get into this semester. So Wednesday and 13th, review stresses in soil. And then 15th, we kind of talked a little bit about consolidation. So we're going to recap that in Geotech 1. And then after that, it'll be all new stuff: consolidation settlement, settlement in clays, settlement in sands. So long-term and short-term settlement, and then shear strength and different tests. And then your exam 1 will be on weeks 1 through 7. We'll have an exam review. And then the second half of the semester, we'll be doing all the foundation design. And so we'll be doing shallow and deep foundations on that there too. This is, of course, subject to change, but hopefully I've covered all my bases with random things that pop up. A few key dates to note: January 20th, that's Martin Luther King Day. So that's not next week, but the week after. And I feel like this whole semester has already been shifted up or backwards or something. So that is, we won't have class that day. March 5th, I'm not going to have any class or video lecture just because that's the ASCE conference. I'll be traveling for that. I know a lot of you guys will be too. So I just wanted to, that's usually like a makeup day anyways. We can just make it work through that. And then there are going to be some days where it's only a video lecture. So the 3rd and the 12th will for sure be video lectures. But you guys also know we have an 8-month-old and a 2-year-old who like to get sick every other week and stuff. So I might have to call audibles some week and teach remotely. But they'll just be recorded and I'll post them during the class time so you can still watch it during that time, everything. And spring break is like, did they change it? Did you guys see this at all? I swear they changed spring break, right?
They shifted down.
Yeah. Okay. I was so pissed. I was like, I thought it was the week before, and I even put in my calendar. I was like, I'm gonna be ahead of time. Like last October, like I was like, this is when our spring break is, and yeah. So whatever. Just a heads up. Apparently, if you didn't know already, it's March 17th and 19th that week. So yeah. Are there any questions right off the bat for tentative for the schedule, for the class, for the structure, anything like that? Okay, cool. So in about an hour, I will post on Canvas the lecture note shells. There should be a tab that says like lecture shells or something, or like, I don't know, like presentation shells, something like that. I will post this one because I know I didn't post this one yet. They will be posted as PDFs, and I'll also post Wednesdays. Wednesday is when we are going to start reviewing geotech stuff. So really important to start, like, if you have some time, just at least to refresh it, look over some of the stuff from geotech again a year ago, but I know it seems like forever ago. And then since this is the first week, we will have a quiz. That quiz will be based off of the syllabus and based off of the review material from tomorrow or for Wednesday. But we have to have like a quiz or an assignment the first week. So please make sure to do that. Well, cool. Well, I hope you guys have a good first day back. Welcome back. And that's it for today. So thank you guys.